Here we have that of geometric distribution. And the parameter for the geometric distribution is P. We also know from probability that this Q is equal to 1 minus P. So before we factor this out, we have to write this properly. F of xi and P, which is the parameter, will be P 1 minus P raised to the power of x minus 1. Before we can now factor out. How do we factor out? I've said it already. Factoring this out is quite simple. It's just taking the sum, that means the product sum of all of this. That means if we have our function to be x1, x2, xn, and we put our parameter p, to factor this out, we are supposed to write something like this. This sign means product, and it's taking the product of this function. If we want to take product of this function, we have here to be p 1 minus p x1 minus 1. We also go again, multiply by p 1 minus p x2 minus 1 multiplied by p. Since this is a constant, we have n here. It will be 1 minus p xi's minus 1. So if we bring these together, we get something like this. F of x 1, 2 to n, and our parameter. This will give us p n 1 minus p summation of xi's minus 1 here. I ranging from 1 to n. Sorry, since this is a constant 1, you have it as n, because if you sum a constant, you have n. So this is what we have. How do we factor this out? Factoring this out, we get something like this. F of x1, x2 to xn and p is equal to p raised to the power of n 1 minus p summation of xi minus n multiplied by the same one. This is because the whole of this function, they depend on p. You can't separate it easily. So this will now give us our function, summation of xi's. We put down the function p, the parameter p, and this will give us h is equal to x1, x2 to xn. Hence, summation of xi, that means I ranging from 1 to n, is a sufficient statistics for p, since p is the parameter we are dealing with. So this is how to resolve that of the geometric distribution when it comes to factorization theory. So whenever you go through it, you just see how you can factor it out. Once you factor it out, it means you are obeying the theorem, the factorization theorem for sufficient statistics.